So we continue with the chapter spectrum and we move on to the next section, next part of the chapter, that is electromagnetic spectrum. Now in the earlier chapter we studied that the visible light, which is the white light, is divided into 7 colors, which is called as a visible spectrum. So we have that there is a visible spectrum. What we already have seen is the one which is going to be starting with, if I say about the Armstrong, it is 4000 Armstrong, so like 8000 Armstrong, and that is going to be this is the violet and this is the red color. So this is the visible spectrum. Okay, so the visible spectrum is the one which is violet, indigo, blue, green, yellow, orange, red. So that is what is we know up till now. So we know that the visible spectrum is from violet, indigo, blue, green, yellow, orange, red. That is the visible spectrum. But the rays of the sun which are entering the earth's surface, they do not contain only this particular visible spectrum of light. They also contain some more amount of different wavelengths or different waves of light which are invisible to us. We are unable to see those particular rays of light which is coming over here, and that is called as the invisible part of the spectrum. The invisible part of the spectrum is spread on both sides of this visible spectrum. It is also on this side, that is the violet side is also there, and also on the red side. So the visible spectrum is in between, and there are the ones which are having the wavelength greater than this than 8000 on this side and less than 4000 on this side, and that particular whole spectrum what you see is the electromagnetic spectrum. So seeing that thing in a shorter way, we can see that violet ke pehle wala jo hai, that is ultraviolet, that is UV. UV ke pehle one which is an X-ray, and then the last one over here is gamma rays. So gamma rays, X-rays and UV rays, ultraviolet rays, are the one on the violet spectrum. On the red side, on this side is infrared. So infrared is the one which is the first one, and then there is the microwave, and finally it is the radio wave. So these are the radio wave. So this complete thing over here is the electromagnetic spectrum. So electromagnetic spectrum, of course you don't have an end line over here because it is just so gamma is on the extreme left and radio is the extreme right. Considering that radio waves, the wavelength is the highest, and the gamma rays, the wavelength is least. Accordingly, the frequency of this is the highest and frequency of this is the least. So that will be the way the particular spectrum of the, we can say the invisible spectrum of light is going to take place. So let's see in detail about these particular different electromagnetic spectrum. Classification. Till now we have limited ourselves to the spectrum of light which lies between the red and the violet region. The spectrum is a visible spectrum and it is only a very small part of the entire electromagnetic spectrum. Experiments show that the spectrum of the sunlight is limited not only between the violet and green extremes, but it extends to on either side beyond these extremes, to which our eyes do not respond. The part of the spectrum beyond the red extreme and the violet extreme is called as the invisible spectrum. So this part and this part, the red parts on both sides over here, whatever written over here, the red colored thing, whatever written over here, are called as the invisible spectrum. The waves of the wavelength longer than the red part of the visible spectrum in increasing order of the wavelength are infrared, microwave and radio wave. So infrared radiations, microwaves and radio waves, while the waves of the wavelength shorter than the violet part of the visible spectrum is decreasing order of wavelength are ultraviolet rays, X-rays and gamma rays. These radiations together form the electromagnetic spectrum. So this is the electromagnetic spectrum from gamma rays, X-rays, UV rays, visible spectrum or visible light, infrared wavelength, microwave and radio wave. So the complete electromagnetic spectrum in the increasing order of the wavelength or decreasing order of the frequency is given by gamma rays, X-rays, ultraviolet rays, visible light, infrared radiations, microwaves and radio waves. The electromagnetic waves are of different wavelengths, but they have properties similar to the light waves. So you can see that the electromagnetic waves, so whatever electromagnetic waves you are seeing, they have the different wavelengths. The wavelengths are different, but they have certain properties which are similar to that of the light waves, that is the visible light. The visible light का जो spectrum है, that उसके comparison में they also have similar properties to those. For example, each wave travels with a speed of equal to 3 into 10 raised to 8 meter per second in vacuum or in air. So here again we can we see this thing, that suppose we can say over here that, like they are given here that in nanometer the gamma rays has got the wavelength as 10 raised to minus 2, and that of the its frequency is 3 into 10 raised to 8, 3 raised to 10 raised to 8, 3 raised to 10 raised to 19. Now this is the hertz. So you will always find that this over here is nanometers. This is nanometers. So if you see velocity is equals to, this is the lambda and this is the frequency, is equals to f lambda. Velocity is f lambda. F is nothing but 3 into 10 raised to 19. And this is 10 raised to minus 2 into 10 raised to minus 9. Why? Because it is nanometer. Converting into meter, it will be multiplied by 10 raised to minus 9. Right? Accordingly, it will be 3 into 10 raised to 9 into 10 raised to minus 11. One sec. Let me check this thing. 9. Sorry, this is 19. Yeah. This is 19. So accordingly, it becomes 3 into 10 raised to 8 meter per second. So you can see that the speed of any of these, the speed of any of the spectrum is 3 into 10 raised to 8 meter per second only. It is not different. The speed of the different spectrum of the electromagnetic spectrum, they are all same throughout. It is same throughout the whole spectrum. Right, so we see that the speed c, frequency f and the wavelength of electromagnetic wave are related as c is equals to f lambda, or v is equals to f lambda, or c is the speed of light, is equals to f lambda. So they are taken this as not v, but they are taken as c because it's the speed of light. The complete electromagnetic spectrum is shown in the figure 10.1, that is this particular figure, with the wavelength increasing towards the right or frequency increasing from the left side. So they have given you the complete details, the complete spectrum, right? Gamma rays, X-rays, ultraviolet, visible light, and the infrared, microwaves, and radio waves. Note, in the figure 6.1, although we have shown the boundary line in each wave, but there is no sharp boundary of wavelength or frequency between the two successive electromagnetic waves. In fact, they overlap to a great extent. So yes, we cannot have a boundary. हाँ ये इधर आ गया तो अभी बस अभी ये गामा है और ये X-ray नहीं. You cannot make it out. There will be a overlapping of the frequencies in case of gamma rays and X-rays, in case of X-rays and UV rays, in case of UV rays and ultraviolet rays, UV rays and visible light. There will always be an overlapping of the frequencies around there. The infrared spectrum is a part of the spectrum through which beyond the red end, while the ultraviolet spectrum is a part of the spectrum just before the violet end. So you can easily make out that red end के वहाँ पे infrared वाला part is just after the red one, and here just before the violet is the violet one. Okay. So we continue. The table below shows the different waves of the electromagnetic spectrum in order of their increasing wavelength along with their discoveries, sources and method of detection. So the first one is gamma rays. Wavelength is below 0.01 nanometer. Discovered by Becquerel and Curie. Sources in cosmic rays from radioactive substances. And method of detection by their large penetrating power. We are going to learn in detail about certain things. So certain kind of things will be given later on with the properties of that particular thing. So right now we are just going through these things in a single manner. X-rays wavelength 0.01 to 1.0. Discoverer was Roentgen. Sources from a heavy metal target of high melting point when highly energetic electrons are stopped by it, and method of detection by fluorescence produced on a zinc sulfide screen. The photographic film gets affected. Ultraviolet light 1 to 400 nanometer. Discoverer was Richter. Sources is sunlight, arc lamps and sparks. Method of detection by their chemical activity on dyes. Photographic plates get affected, it causes fluorescence. Visible light 400 to 800 nanometer. Newton was the discoverer. Sunlight, light from electric bulbs, flames, white hot bodies are the sources. And method of detection, other objects can be seen in its presence. Name of the wave is infrared. It is from 800 to 10⁶ nanometer. Herschel was the discoverer. Lamp with thoriated filament, heated silicon carbide rod, red hot bodies. Method of detection, heating effect is more. The mercury rises rapidly when a thermometer with a blackened bulb is kept in these radiations. Microwave 10⁶ to 10⁻10 Hertz. Electronic devices such as crystal oscillator sources, and the detection is oscillatory electrical circuit. Finally, name of the wave is radio wave, and the wavelength is about 10⁻10, and discoverer was Marconi. Sources were TV and radio transmitters, and method of detection, areas of radio and television receivers. So this was the different kinds of the waves with their wavelength and the sources, discoverer and the method of detection. Normally the sources discoverer is not required to be learned, but method of detection, yes, they do ask method of detection in certain cases. So that's why you do go through or learn the method of detection of these particular kind of waves. Now approximate range of wavelength and frequency. Gamma rays wavelength shorter than 0.1 angstrom or lambda less than 0.01 nanometer, or frequency about 10⁻19 Hertz. X-rays wavelength 0.1 angstrom to 100 angstrom or 0.01 nanometer to 10 nanometer, or frequency 3 into 10⁻19 to 3 into 10⁻16 Hertz. Ultraviolet rays wavelength 100 angstrom to 4000 angstrom, that is frequency 3 into 10⁻16 to 7.5 into 10⁻14. Visible light 4000 angstrom to 8000 angstrom, or frequency 7.5 into 10⁻14 to 3.75 into 10⁻14 Hertz. Infrared radiation from 8000 to 10⁻7 angstrom, and the frequency 3.75 into 10⁻14 into 3 or 3 into 10⁻11 Hertz. Microwave 10⁻7 angstrom to 10⁻11 angstrom, or frequency 3 into 10⁻11 to 3 into 10⁻7 Hertz. Finally, radio waves above 10⁻11 Hertz, frequency 3 into 10⁻7 Hertz. So these were the approximate values of the wavelength and the frequency not required to learn. Okay. Property is common to all the electromagnetic radiation. Now this is something very, very important. We need to know certain properties which are very important, and they are the one which are common to all these. Okay, some of these are one which not all, these are the one which are common to all these kinds of the waves. So first one is electromagnetic waves do not require any material medium for its propagation. So electromagnetic waves, they are the light waves which do not require any material medium for their propagation. So that's the first and foremost thing. None of these waves require material medium for its propagation. Second, they all travel with the same speed in medium. In, for example, vacuum or speed is 3 into 10 is to 8, and glass is speed is 2 into 10 is to 8 meter per second, and so on. So it is seen that they all these travel at the same speed. Okay, they are going to travel at the same speed in air, that is 3 into 10 is to 8 meter per second, and in glass the speed is 2 into 10 is to 8 meter per second, and so on. They exhibit the properties of refraction. In refraction, when an electromagnetic wave passes from one medium to another medium, there is a change in its direction of travel, speed and wavelength, but its frequency remains unchanged. So when there is the wave, that is one wave is going to travel from one medium to another medium, there is going to be refraction, and due to refraction there will be a change in the path, and there you will find that there will be a change in the speed and the wavelength, but there will not be any change in the frequency of that particular thing, because frequency is the property of the light based on its source, and here because the source doesn't change, that's why the frequency does not change when it is traveling from one medium to another medium. And fourth one is these waves do not deflect, are not deflected by electric or magnetic fields. These are not charged things, so they do not have any charge on it, and due to this they do not get deflected by electric or magnetic fields. And finally, the fifth one, these waves are transverse in nature. They are transverse in nature. Sinusoidal. This is sine wave. So this is the way it is going to travel. It is not going to be longitudinal like the compression and refractions. No, it will be traveling in crest and troughs. So they are all transverse in nature. Now we will be seeing the properties and uses of different things over here. We will not be studying each and everything in detail, but at least these two, that is ultraviolet and infrared, we will be seeing in detail. Otherwise, we are just going to see a small paragraph on the other 1, 2, 3 and 4 waves. So first one is we are studying is gamma rays. So we are starting with the one which has got the lowest of the frequency of the wavelength, that is gamma rays. These are the most energetic electromagnetic radiations of wavelength less than 0.1 angstrom or 0.01 nanometer. So yes, the wavelength is very small, but they are most energetic. Why they are most energetic? It's a simple thing. They have got a huge frequency. What do you mean by frequency? Number of waves per second. You can imagine the number of waves per second of a gamma rays is around 3 into 10 raised to 19 hertz. 3 into 10 raised to 19 hertz means 3 के बाद 19 zeros, उतना times it can move in 1 second. So you can imagine how great will be the kinetic energy of that particular thing. So it is the most energetic wave, that is a gamma ray. So gamma rays, because they are very energetic, they will have a very high penetration power. See, whenever something is with a huge kind of a frequency, that means that has got a very high amount of energy, so they will always be able to penetrate inside very easily. So sources, they are obtained in radioactive emissions when the nucleus of the radioactive atom passes from an excited state to a ground state. They are also present in cosmic radiation. So when the radioactive radiations takes place, so gamma rays is one of the rays which is going to be given out by the radiation of the nucleus splitting. So nucleus जब split होता है, we are going to learn that splitting of the nucleus in the last chapter of physics, that is radioactivity. So in that case we come to know that there are alpha, beta and gamma. So gamma rays, what is being generated over there is nothing but this gamma rays, which is a part of the spectrum. So yes, they are present in the cosmic rays also, and they are present when they are the radioactive atom gets excited to the ground state. Properties like X-rays, they cause fluorescence when they strike the fluorescent material such as zinc sulfide. Okay, zinc sulfide, when it is hit by this ray, it glows. You know, there is a fluorescence. So a fluorescent light, वैसा fluorescence होता. So that is one property of these lights, that these lights, this when they hit a particular zinc sulfides kind of a layer, that layer shines. They can easily penetrate through a thick metallic sheet, 30 centimeter thick iron sheet, 30 centimeter, 1 feet. Okay, इतना ज़्यादा अगर आयन का थिक ये रहेगा तो उसमें से भी ये पास हो सकता है. So you can imagine how great will be the penetration power of this gamma rays. Gamma radiation easily pass through human body and cause immense biological damage. Yes, they can pass through our human body and they can cause immense damage to the human body by passing through them. That's the reason the nuclear power plants and all, you need to wear special suits so that the gamma rays which are being there, they do not affect your body so easily. Uses, they are used in medical science to kill cancer cells, radiotherapy, and in industry for checking welding. So yeah, what they do is that they, in our body, because they are going to cause damage to the cells, biological cells of our body, तो जहाँ पे हम लोग को cells को मारना है, and in those locations we are focusing that these particular rays over there so that those cells are killed. So normally we do this for cancer treatment. So cancer treatment, the radiotherapy is using the gamma rays, and also when you have got thick kind of a tanks and all made for different kind of chemicals, there the welding, what is done to check the welding and check to check whether there is no cracks or any kind of a fault in the material, they use these kinds of gamma rays for detection of the cracks or the problems in the welding over there. So that is the uses of gamma rays. We now move on to the X-rays. So X-rays are obtained from a heavy metal target of high melting point when highly energetic cathode rays or electron beams are stopped by it. They are wavelength in the range 0.1 angstrom to 100 angstrom. So you can see they are basically heavy metal target of high melting point. So X-rays are obtained from, so they are going to take a heavy metal. So heavy metals are basically those metals having the atomic mass much higher. This atomic mass is around 150 plus. So they take the heavy metals. So unke heavy metals mein the electrons are free to move around, so easily move on ho sakta hai. But then they are going to energize that thing. So accordingly the electrons are going to get emitted. The electrons which are emitted are nothing but the cathode rays. So that cathode beam rays are going to cause the X-rays to be formed. So when these the cathode rays are being stopped, the X-rays are going to be formed. Properties: X-rays are chemically more active than the ultraviolet radiations. They strongly affect the photographic plate. Like gamma rays, they cause fluorescence in certain material like such as zinc sulfide, etc. They can penetrate through human flesh, but they can be stopped by the bones. So X-rays are something which can have, they are slightly, of course they are less energetic than gamma rays, but slightly more energetic than the ultraviolet rays. तो उसका penetration power बहुत ज़्यादा नहीं है, but more than ultraviolet rays. So this penetration power is such that it can pass through our muscle and the flesh, but it cannot pass through the bones. And that is the reason it is being used for the detection of bone fractures. So bone के अंदर क्रैक वगैरह दिखने के हम लोग क्या करते हैं, एक्सरे लेते हैं. तो हम लोग देते ही एक्सरे. एक्सरे क्या होता है? That is this X-rays are being put on your that particular part of your body so that the photographic film is placed. So the light rays will pass through the flesh, but it will not pass through the bones. And जहाँ जहाँ bones है, वहाँ पे you will find that the white color block आ जाएगा. जहाँ जहाँ पे pass हो पाया, वहाँ पे it will be black. So accordingly, it is the affecting the photographic film. So uses, they are used for the detection of fractures in bones, teeth, etc. That is radiography, and for diagnostic purposes such as the CAT scan, In medical science, X-ray is also used for study atomic arrangement in crystals as well as in complex molecules. So they are not only used for the medical purposes, they are also used for studying the molecular structure or the atomic structures or the crystal structures as well in the complex molecules. X-rays are used for the detective agency to detect the concealed precious metals. So detective agency is going to use this to detect the concealed precious metals, and that you can always see when you are going to when you go abroad or anyway, basically when you are going to go take a flight, your complete this luggage is being made to pass through an X-ray machine. So in the screen they see that what exactly is there in the, is there any kind of a inflammable thing or something which is not allowed in the flights that is passing through it, whether it is there in that particular hand luggage or not. So that is where they use the X-rays to detect the presence of the precious metals concealed in the metals. The next we see is the ultraviolet radiation. That is ultraviolet. We are going to see this thing in a bit detail. We will be having the properties of the ultraviolet radiations also. So that is the ultraviolet radiation. The electromagnetic radiation of wavelength from 100 Armstrong to 4000 Armstrong are called as the ultraviolet radiation. The ultraviolet part of the spectrum was first detected by Professor J. Reiter in 1801. Detection: if silver chloride solution is exposed to the electromagnetic wave starting from red to the violet end and then beyond, it is observed that from the red to the violet end the solution remains unaffected, but beyond the violet end the solution first turns violet, then finally it becomes dark brown or black. It shows that there exists certain radiations beyond the violet extreme of the visible part which is chemically more active than the visible part. This radiations are called as the ultraviolet or actinic rays. So it is seen that when silver chloride solution is taken and you are allowed to pass and you are allowing it to waves of visible light to pass through it, तो पहले कुछ भी नहीं होगा, red तक कुछ भी नहीं होगा, but as soon as you go on increasing that spectrum और उसमें violet जब भी pass होगा तभी भी कुछ नहीं होगा, but as soon as you go beyond violet का spectrum and you reach this ultraviolet radiations, there you will find that the color is going to become violet. It will become violet color, solution becomes violet, and then slowly it will become dark brown. So you can see that suddenly the change is taking place. So there is more reactors. So you can see the reaction taking place will be more in the ultraviolet radiations, which is given over here. The ultraviolet radiations can be detected by the chemical activity of dyes and photographic plates. The spectrum of ultraviolet radiation is obtained when they are passed through a quartz prism in place of a glass prism because glass absorbs this radiations. So whenever you want to have an ultraviolet radiation का अगर तुमको spectrum चाहिए, तो that spectrum requires the quartz. Quartz is the type of material. So quartz prism is required for those things. You cannot use glass prism because glass is going to absorb the ultraviolet radiation. So because glass absorbs the ultraviolet radiations, that's why you cannot use the glass prism for generation of the spectrum of the ultraviolet. So this is also a very good give reason question. So just keep it in mind. Sources of ultraviolet radiation: the electric arc and sparks give ultraviolet radiation. A mercury vapor lamp emits radiation, a part of which has ultraviolet radiations along with the visible light. Sun is also a source of ultraviolet radiation, but a large fraction of it is absorbed in the ozone layer present in the Earth's upper atmosphere, which protects us from its harmful effects. So we very well know that it's the ozone layer which is going to stop the ultraviolet radiations of the sun to enter into the Earth's atmosphere. Properties of the ultraviolet radiation: ultraviolet radiation can pass through quartz, but they are absorbed by glass. Therefore, to obtain the ultraviolet spectrum from its source, a quartz prism is used instead of glass prism. For the same reason, the ultraviolet bulbs have the envelope made of quartz instead of glass. These radiations travel in the light straight line with a speed 3 to 10 meter per second in air or vacuum. They are usually scattered by dust particles present in the Earth's atmosphere. They obey the laws of reflection and refraction. Okay, they are all going to obey the laws of reflection and refraction. They strongly affect the photographic plate as they are chemically more active than the visible light. They produce fluorescence on striking a zinc sulfide screen. So these are the different properties or special properties of UV rays or ultraviolet radiations. Harmful effects. The ultraviolet radiations can cause health hazards like skin cancer if human body is exposed to them for a longer period. And uses of ultraviolet radiation is used for following purpose, for sterilizing purpose. Yes, UV rays are used for sterilizing purpose because it kills a lot of bacteria by it. For detecting purity of gems, eggs, ghee, etc. So it detects the purity of this particular thing. It is used, some kind of a bulb is there, it's used over there. In producing vitamin D in food for of plants and animals. Okay, so this is the three important uses of ultraviolet radiation. The next what we see is the visible light. The electromagnetic radiation of wavelength from 4000 Armstrong to 8000 Armstrong are called as the visible radiation or visible light because it is presence of this radiation other objects are seen by us. We call it visible light because we are able to see things only because of the presence of this particular light. The visible part of the spectrum was discovered by Newton while passing the sunlight through a glass prism. The prominent colors of the visible light are violet, indigo, blue, green, yellow, orange, red. Sources: the sun, electric bulb, flame or white hot bodies and are the main sources of visible light. Uses: the visible light is used in photography, in photosynthesis and to see the objects around us. That was about the visible light. We stop here and we'll continue in the next video.